Okay, so last time we talked about arithmetic sequences in series. Do you guys remember? So arithmetic sequences in series, you added what we call a common difference. So it's like when you added 2 each time or subtracted 7 each time. So now we're going to talk about geometric sequences in series. And a geometric sequence is when you multiply by the same thing, or divide. I mean, division is the same as multiplication, right? Dividing by 2 is the same as multiplying by 1/2. So this is when you multiply by what we call a common ratio. So instead of D for common difference, we're going to have R for common ratio. Okay, so for the sequence A1, A2, A3, A4, A5, remember before our common difference was any term and you subtract out the term before it. Now it's going to be any term and divide out the term before it. So you could have like A2 divided by A1. You'd have A3 divided by A2, A4 divided by A3, and so on. So those will all equal R. Okay. Just like before, remember we talked about if I had 5, 7, 9, 11. We said our common difference was 2 because we add 2 each time. You could do the 7 minus the 5 and you'd get 2. But I think it's easier just to say what do you add each time. So in this case, we're saying what are we multiplying by each time. So if I have 2, 4, 8, 16, what's my common ratio? 2. Yep, because each time you're multiplying by 2. So yes, your common ratio would be 2 then. So you can show all that side work and you can say, okay, is it equal to 4 divided by 2? Is it equal to 8 divided by 4? 16 divided by 8? Yeah, they're all equal to 2. All right, now this one's a little bit harder. So what are you multiplying by each time here? So the numerator stays the same, so it's 1 over something. 1 over 3. Does it work each time? Multiplying by 1 over 3, multiplying by 1 over 3. Yep. So yes, this common ratio is 1/3. So we usually talk about, like with common difference, we say what are we adding each time, and it can be a negative number. With common ratio, we usually say what are we multiplying by each time, and it can be a fraction. You know, multiplying by 1/3 is the same as dividing by 3. All right, so that brings us to our formula. So nth term of a geometric sequence. Remember we talked about last time if I started with the first term and I wanted to get to the third term, you had to add the common difference twice. Now that we're talking about a geometric sequence, we're going to have to multiply by our common ratio twice to get to the third term. Okay, so if I want to get to the nth term, so a sub n, I'm going to start with my first term, and I'm going to multiply by r how many times? N minus 1, right? 1 less than n. Remember here it was 2 times and we wanted to get to the third. If I wanted to get to the 7th, I'd need it 6 times. All right, so it's going to be multiplying by r n minus 1 times. So it's an exponent. If it was 5, you'd have r times r times r times r times r. You'd have r 5 times. Okay, so it's just like the ones we did yesterday, only now we're multiplying by our common ratio. Okay, so number 1 says find the common ratio of the geometric sequence with a1 is equal to 3 and a2 is equal to 12. Okay, so that means I have 3 and then I have 12. What's my common ratio then? 4, right? Did you guys see it? You just multiply by 4. So r is 4. And then it says write the first 5 terms of the sequence. So we already have the first 2. The next one's going to be 12 times 4. Then it gets big, so you guys can use your calculator. 48 times 4 is, and then 192 times 4 is, yep. So 3, 12, 48, 192, 768. Okay, number 2 says write a formula for a geometric sequence where the first 2 terms are 3 and negative 3/4. Then find the first 5 terms of the sequence. Okay, so if I have that, if I want to find r, I don't really have a hard time with this. I mean, I think of like 3 as 3 over 1, and I say what do I need to multiply by in order to get negative 3/4? but some of you guys might have trouble with it. So what do you think, Kern? Negative 1/4, right? You need negative 1/4. So on the top, you need negative 1. On the bottom, you need 4. So if this is difficult, find A2 divided by A1, right? Any term divided by the term before it. So that's negative 3/4 divided by 3. And you can actually do that on your calculator for those of you that are scared of fractions. So you can do negative 3/4, take that answer and divide by 3. And then you can go to math, fraction. Hopefully you guys know what negative 0.25 is, but if you don't, math, fraction, and you get negative 1/4. Okay, so anyway, so we know our common ratio now. So we want to find the first 5 terms of the sequence. So each time I'm going to multiply by negative 1/4. So if I have negative 3/4 and I multiply by negative 1/4, multiply across the top, multiply across the bottom. So negative 3 times negative 1 is 3. On the bottom I get 16. Now I'm going to take 3 over 16 and I'm going to multiply by negative 1/4. So I get negative 3 over 64. And then multiply by negative 1/4 again. So you get 3 over 256. Those are the first 5 terms. Okay, so now it gets a little bit harder. It says the 4th and the 7th terms of the geometric sequence are negative 18 and negative 486. Find the 5th and 6th terms of the sequence. Okay, so A4 is negative 18. A7 is negative 486. Okay, those are the only 2 things I have, so I need to come up with some kind of formula that relates the 4th term and the 7th term. Okay, so just like we did yesterday with our arithmetic, if I was going from the 4th term to the 7th term, how many common differences did we add? You guys remember? 3, right? If I went from the 4th to the 7th, I would add my D 3 times. But this isn't adding anymore, it's a geometric sequence. So when you see a geometric sequence, that's your R, you're multiplying by R. So if you're going from the 4th term to the 7th term, you're going to multiply by R 3 times. So you start with A4, you would need to multiply by R 3 times in order to get A sub 7. So the terms have subscripts. R is raised to a number. It has an exponent. So A sub 7 is negative 486. A sub 4 is negative 18, and we have R cubed. Negative 486 divided by negative 18 is 27 equals R cubed. How do I get rid of my cube? Cube root, so cube root of both sides. So I get R equals 3. So my common ratio is 3. So when it says find the 5th and 6th terms, we know the 4th term is negative 18. You can write a formula that relates the 4th to the 5th, or the 4th to the 6th. But basically, I know if I'm trying to get to the 5th term, I'm going to multiply by 3. So I'm going to have negative 18 times 3, so negative 54. And if I'm trying to get to the 6th term, I'm going to take that, and I'm going to multiply by 3. Negative 3, I guess. Oh, no, 3. Yeah. So I get negative 162. So those are the 5th and 6th terms. Okay. Now sometimes they are kind of tricky. So what if this had been, so what if you had R squared equals 16? What would R be? Just 4? Plus or minus 4? r equals plus or minus 4. Okay, so basically what that would mean is that you could have an alternating sequence. So each time one would be positive and then negative and positive and negative if r was a negative number, right? Each time you, so like let's say we started with 2. If r was negative 4, it'd be negative 8. Then if I multiply by negative 4, I get 32. Then multiply by negative 4, you get 128, negative 128. So see how it alternates sign? So it could be that sequence. Or if r had been 4, it could have been 2, 8, 32, 128. It could be a non-alternating sequence. Okay, it just depends. So you could have 2 answers for your sequence. So it could have 2 possible sequences. Okay, so it says if the common ratio is 1, then you don't have a very interesting sequence, right? If, let's say your initial term was 5, like your first A1 was 5, and R is 1, what's the next term then? 5, and the next one's 5, 5. So you just have the sequence 5, 5, 5, 5, 5, 5. Not interesting. So we never really talk about the common ratio being 1 because it's not creating an interesting sequence. It's just the same number over and over. Okay, so if that happened though, then your kth partial sum would just be whatever your first term was plus whatever your next term is plus whatever your next term, and they're all the same thing. So if you add up k of those items, so if I have a number k times, we say it's a1 sub k, or a1 times k. Right, if I had 5 10 times, it would be 50. You multiply them together. 5 plus 5 plus 5 10 times. All right, so we don't really talk about when the common ratio is 1. We usually talk about when it's not equal to 1, which is what it says in this definition. Okay, so the sum of a finite geometric sequence, so A1, A1R, A1R squared, A1R cubed, and so on, is given by A1, I always forget this formula, I gotta look it up, I give it to you. A1, 1 minus r to the n. 1 minus r to the n over 1 minus r. Okay, this will be the one formula you will get for your test. Okay, so it says find the sum of negative 5 over 2, 5 over 4, negative 5 over 8, plus 5 over 16, and so on. Okay, first we need to know how many terms there are. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have 9 terms. So that means I'm finding the sum of the first 9 terms. So we call it the ninth partial sum. Okay, then we want to know what our common ratio is. So can you guys find R? So what do you multiply in order to get to the next thing? Negative 1/2. Can you guys all do that? Yeah, think about what you need to multiply across on top and think about what you need on the bottom. So in order to get to the next term, you would need negative 1 on top to go from negative 5 to positive 5. And on the bottom, you would need 2. All right, A1, we know. A1 is the very first term, so it's negative 5 over 2. So we have all the items that we need. We know R is negative 1/2, A1 is negative 5 over 2, and N is 9. We have 9 items. So we can plug into the formula. So A1 is negative 5 over 2. I have 1 minus R is negative 1/2 to the 9. Make sure you put R in parentheses. All over 1 minus a negative 1/2. We're going to use our calculators to help us. So take your calculator and in parentheses put negative 1/2 so negative 1 divided by 2 in parentheses, and raise it to the 9. When you guys do that, you should get negative 0.001953125. Are you guys all getting that? Okay, we want 1 minus that answer for our numerator, so do 1 minus the answer. So you have 1.001953125. Do you guys all have that? Here, I'll write out. I don't usually write out these steps, but it might help. 0.001953125. All right, now on the bottom, what are you going to have? So on the bottom, we want to divide by, do you guys see how it will be 3 over 2 or 1.5? Okay, if you guys don't know that, then do divided by, so hit divided by. So say it says answer divided by on your calculator. It says this. Put parentheses, and you're going to do 1 minus parentheses negative 1/2. So I put on my calculator answer divided by 1 minus negative 1/2, like that. You guys should have 0.66796875. Do you guys have that? Oops. All right. So you have negative 5 over 2 times 0.6679. I'm only writing these numbers for your notes. Okay, so your last step is to now multiply by negative 5 over 2. So say times negative 5 divided by 2. So you get negative 1.6699, something like that. All right, now this is a fraction. I mean, all of those things that we dealt with were fractions. So you can hit math 1, and it should go to a fraction. Oops. So it's negative 855 over 512. Do you guys get that? Okay, sometimes it's so many digits that your calculator can't convert it back to fractions. Like your calculator does rounding errors sometimes. Like it only has so many like bits and bytes and stuff in the calculator. So it can't hold it all sometimes. Okay, but I prefer to see the fraction form if it will let you. So make sure you're keeping your answer in your calculator and computing them. Okay, does that make sense? Okay, you guys could also try to add all those together. I mean, that wouldn't be hard. You have 9 terms. But remember on your test, I might ask you, like, find the sum of the first 20 terms. So I won't be that nice on your test, right? Okay, so question. Would you rather get paid $10,000 every day for 30 days or get paid 1 cent the first day, 2 cents the second day, 4 cents the third day, 8 cents the fourth day, and so on until the 30th day? I just made this up, so I know you've seen things similar to this, but they could be close. Okay, so think about it. Let me get my computer charger real quick. So think about how much you'd make in each situation. So try to do some little preliminary sketches. Okay, so raise your hand if you think you'd rather get $10,000 every day. Raise your hand if you think 1 cent, 2 cents. You guys just have no idea. So 2 people think $10,000 every day. The rest of you guys have no idea. Okay, so we'll try. All right, so this is a geometric series. So a series is just adding up all the terms of a sequence. It's geometric because you're doubling your amount each day. So your ratio, R, is 2. Your first term, A1, was 0.01. And how many terms am I adding together? So what's N? 30, because you're going to do it 30 times, right? 30 days. All right, the $10,000 every day just means you're going to get $10,000 every day for 30 days, so times 30. So you get $300,000. That's pretty good. I'll take $300,000 a month. So let's see on this one. So we're going to use our formula. So the A1 times 1 minus R to the N over 1 minus R. Okay, your first term is the 0.01. You're going to have 1 minus R is 2, so 2 to the 30 over 1 minus R, so 2. Okay, so try it. So try to figure that out on your calculator. See if you can do all the steps correctly. You guys should get $10,737,418.23. So they're not even close. So the reason is because that doubling happens very quickly. I mean, if you just do 2 to the 30th alone, that would be, let's see, well, 2 to, I guess, yeah, we start with, so 2 to, that doesn't make any sense. I won't explain it that way. All right, so do you guys see how you would have a lot more money after 30 days? So we like things that double. It's much better. All right, so the sum of an infinite geometric series. So if you have something that is, if you have 1, 2, 4, 8, so if you're doubling, and you have an infinite number of terms, if you're adding them together, obviously it's going to go to infinity. Does that make sense? Like you're going to have an infinite number. It's just going to keep getting bigger and bigger and bigger. But you can add up an infinite number of terms and get something that's finite. So you can get a number that is small. And the best way to think about this is with halving. So let's say I have 1 inch. So this is 1 inch. And now I want to add on half an inch. And then I want to add on half of that. So 1/4 of an inch. And then 1/8 of an inch. And then 1/16 of an inch. And so on. As I keep adding those little bitty halves, what am I getting closer and closer to for the total? Right here. So you're going to add half that, and then half that, and then half that. It's getting closer to 2. Does that make sense? So the whole thing would be getting closer to 2. Okay, so you can add an infinite number of items and get something small, like not infinity. Okay. But the key to that is that your ratio has to be less than 1. Okay, they say absolute value because R can be negative, like you can go positive, negative, and so on. Okay, if that happens, then your infinite sum, notice how they just call it S, not S sub n, because there's not n number of terms, there's an infinite number of terms, so they just call it S, is A1 over 1 minus R. This is kind of confusing, but it says this is because as n gets really large. So let's say you take 1/2 on your calculator. So put in parentheses 1/2. And you raise it to a huge number. So let's raise it to 100. You guys have 7.88609 something times 10 to the negative 31st. So that's scientific notation. That means that you have 0.00000, a whole bunch of zeros. It's really, really tiny. So now let's do 1/2 raised to the 500. Your calculator gives you 0. Is it really 0? No, it's not 0. 1/2 to the 500 is still some number, but it's so tiny that your calculator cannot even compute it. Okay? It's so close to 0. All right, so it says this is because as n gets really large, you have a small fraction raised to n, so you have that small number r raised to n becomes almost 0. Therefore, our equation before, which was a1 times 1 minus r to the n all over 1 minus r, becomes a1 times 1 minus 0. It gets so close to 0 that it's insignificant to our problem. So you end up with a1 times 1 over 1 minus r, which is just the formula that I just gave you. Okay. It's kind of some calculus stuff going on there. So you guys are doing calc. All right, so let's compute the following infinite sum. So when you see infinite or when you see it goes on forever, you're using this formula. So you're saying S equals A1 over 1 minus R. So in this problem, A1 is our first term, so it's 1/2. And R, what's R? What are you multiplying by each time? 2 on the bottom, right? So 1/2, right? So you have, the first term was 1/2. You have 1 minus 1/2. So you have 1/2 over 1 minus 1/2 is also 1/2. You have something over itself, which should be 1. Or you could think of it as 1/2 divided by 1/2, so 1/2 times 2 over 1, which is 1. That's kind of like the example I was showing you. So if you have from 0 to 1, and I have 1/2 plus 1/4 plus 1/8, it's filling that whole space. It's filling the whole 1. Okay, this one's written out a little bit differently. So let's write out the first few terms just so we know for sure what's happening here. Okay, so if you remember, if we have a sigma notation or summation notation, the bottom number tells you where you start. The top number tells you where you end. So it's saying end at infinity. So you're never going to get to the last number. Okay, so your first number is going to be 2 times negative 2/3 to the 0. The second number is going to be 2 times negative 2/3 to the 1. The third number is going to be 2 times negative 2/3 to the 2. And then it's going to go on forever. So let's figure out what those numbers are. So negative 2/3 to the 0 is 1, so times 2 would be 2. Negative 2/3 to the 1 is negative 2/3, so times 2. So if you need to do it off to the side, think of 2 over 1 times negative 2/3. What do we get? Negative 4/3, right? The next one I have 2 times, that ends up being 4 over 9, right? Negative 2/3 squared, so square the top, square the bottom. So you get 8/9, and so on. Now, if you guys get really good at these, you're not going to have to write out the first few terms because you guys are going to be able to see what the common ratio is. What's the common ratio, Kern? 2/3? Close. Negative 2/3. Okay, and where that comes from is it's the thing that's being raised to the power, right? It's saying each time you multiply by one more of those things. So that's your common ratio. So see how you're multiplying by negative 2/3. Okay, so that's R. I also need A1. So A1 ends up being the number out front because the R part was being raised to 0 to begin with. So A1 is 2. All right, so you end up with, so A1 equals 2 and R is negative 2/3. So your infinite sum is 2 over 1 minus a negative 2/3. So be really careful when you put this in your calculator. So go ahead and try to put it into your calculator. So do 2 divided by, and you want to divide by that entire denominator. So put the entire denominator in parentheses. So 1 minus parentheses negative 2/3 parentheses. You should get 1.2 or 6/5. So 6/5. I usually like to see the fraction form. Okay, does this all make sense? They're a little tricky.